Hello, Trinity Tigers. Welcome to the Learning Together live webinar series as part of lifelong learning initiatives presented by Trinity University Alumni Relations and Development. I am Irene Fan, class of 2015, currently working as a program manager at Microsoft's AI Architecture and Strategy team. Trinity's Office of Alumni Relations has invited me to moderate this webinar. It is my distinct pleasure to introduce the webinar panelists. Dr. Mathew Hibbs is an associate professor of computer science at Trinity University. He teaches courses on computer programming, computer graphics, game development, and bioinformatics. Dr. Mark Lewis is a professor of computer science at Trinity University. He teaches courses on computer programming, web development, big data, and machine learning. Both professors played a very important role in my college years. Dr. Lewis was my academic advisor, and Dr. Hibbs was my thesis advisor. Without them, I wouldn't have become a CS major at Trinity. I wouldn't have had the courage or knowledge to pursue a graduate degree and a career in CS. And I wouldn't be moderating this webinar today. So I do want to take this opportunity to say thank you. Now, in 2020, which is 5 years after my graduation from Trinity, by the way, more and more people seem to accept that AI-driven technologies are slowly becoming the new normal. But only a few know that the history of machine learning can be traced all the way back to the 1950s. But it took almost 60 years to convince the most computer science scholars of its potential. Another 3 years to be known for recognizing cats on YouTube, and another 8 years to become the buzzword it is today. In this webinar, the panelists will explore what these technologies really are and how they might impact society and individuals in the coming years. They will address questions such as, what are AI and machine learning, and how do they relate to big data? What are some of the key areas where these technologies have a significant impact? How might we expect these technologies to alter the way we do things in the future? What are the good, the bad, and the ugly of these technologies? Well, before I hand it over to Dr. Hibbs, I would like to remind you that you will be able to submit your questions as you listen using the Q&A tab. And we, including both panelists, will be happy to answer them. Ladies and gentlemen, now I'm turning first to Dr. Hibbs to give his thoughts and perspectives.
Thank you so much for the great introduction, Irene. It's great to see you again. I thought I'd start off with just a little bit of terminology and background, and Dr. Lewis can definitely chime in at any time. Artificial intelligence as a field is really all about making computers and computer programs, quote unquote, smarter, with the ultimate goal of creating systems that can understand and interact with the world in ways that more closely resemble how humans understand and interact with the world. And that concept dates all the way back to the founding of computer science, all the way back to Alan Turing, who's often referred to as the father of computer science. One of the ways that he framed artificial intelligence was in the form of a test, where a computer program would have a conversation with a panel of actual people. And if it could convince the people that it was having a conversation with that they were talking to another actual person and not to a computer, that would pass this theoretical test of what artificial intelligence should mean. And we now call that the Turing test after him. So it dates back as far as computer science dates back. Machine learning is a subset of artificial intelligence that's really attempting to gain insight from existing data repositories. There's two main classes of machine learning techniques, supervised and unsupervised techniques. Unsupervised techniques don't need any prior knowledge. They're just combing through very large data repositories, trying to find commonalities and patterns that we can generalize from and say something interesting about a collection of data. Perhaps more interesting, especially recently, are supervised machine learning methods, which build from a starting point of knowledge. And given other available data, they try to expand that starting point of knowledge into new discoveries or new predictions of what might be true. So some examples of supervised learning methods would be things like Bayesian networks or support vector machines, or what's been in the news and in the zeitgeist recently are deep neural networks, which are loosely based off of how neurons in the brain function, passing information from one to another. And we can learn weights of how that information is passed through, given training sets and giving labels that the supervised algorithm is trying to extrapolate from. And then we can apply that to new domains. So one of the big areas in recent years that has made huge advances, especially with deep neural networks, is in image analysis, identification of things within images, classification of images, image processing. Part of what made that possible was a collection of labeled images that's called ImageNet that was collected actually by my former PhD advisor, Kai Li, and one of his colleagues, Fei-Fei Li. And they actually used the Amazon Mechanical Turk system, where you can pay people to do simple tasks, to collect billions of images and label what was inside of those images. So think of the captchas that you see when you go to websites, and it's like, click on all the squares that contain a traffic light, right? It's that kind of idea. And so they have these billions of images that have labeled, you know, this is a cat, there's a dog in this corner, there's a boat in that corner, there's an airplane here. And they held a competition, an annual competition, for people to learn from a set of these images and then predict what objects were in other images. And initially, their accuracy was not great. They're about 50 to 60% accurate when presented with new examples. But in the mid 2000s, mid to late 2000s, a group started applying deep neural networks to this problem. And they suddenly shot up in accuracy to like 95% within a year. And then over the course of the next few years after that, they got up to like 99.9% accuracy. And they've gotten so accurate that they've actually stopped holding the competition. They basically consider it solved at this point. So Fei-Fei has some really great videos and lectures out there talking about this competition and what all they've learned from it. And she tends to describe AI as analogous to the development of a child. A 2-year-old or a 3-year-old can point at a cat and say, cat. But you've got to be a little bit older and more mature to form a complete sentence about, you know, what is that cat thinking? Is that woman getting on or off of that plane? And so we're sort of at that stage now of image understanding, where we're trying to put together, she calls it automatic captioning of images, where we can say, you know, a complete sentence about a picture. And even beyond that, we've seen that kind of image processing really permeate our lives. The virtual Zoom background behind me that occasionally sees my chair, that's definitely feeding from some artificial intelligence behind it. Things like Instagram, you know, filters and those kinds of things are all because of this image analysis that we've gotten a lot better at. That said, I will say there's been some controversy, getting to sort of the ugly and the bad of what's going on, in that the training sets that we learn from greatly influence what we learn. And so in the case of image processing, there was a controversy just last week that when Zoom does its automatic person detection, people with darker skin complexions are sometimes not detected. That discovery actually led to a second discovery that Twitter uses artificial intelligence to automatically crop images so that they don't appear too large on your Twitter feed. And it selectively crops out white people over Black people in images. So if you put a very large picture of, say, Mitch McConnell and Barack Obama next to each other, it is much more likely to center Mitch McConnell's face than Barack Obama's face. So there are inherent biases in our data, and that gets reflected in what these machine learning methods can learn. They can't unbias our input data. So moving beyond just image, we're also doing a lot of progress with audio. I'm sure that everyone has an audio device that they can talk to and it can understand your voice. And even my nephew with his very thick Arkansas accent, Alexa can understand, which he loves. And we're trying to get better with that. We've gotten pretty good at just doing standard voice recognition, but now we're starting to move into tonal analysis, trying to understand if someone is angry or excited or happy. And beyond that, even within images, we're starting to look at things like pose recognition. What does a person's stance or stature say about what they're thinking or feeling? So again, trying to get the computer to interact with people in a more natural way. That's a big part of the human-computer interaction field using artificial intelligence now. There's also a lot of creativity applications for artificial intelligence that again has come out of this whole image manipulation stuff. I wanted to show one example that I just like personally. So I'm going to change my background. This is a picture of CSI, and there's a method called style transfer now, where you can take one picture and re-render it in the style of something else. So here's that same picture rendered in the style of Starry Night, or that same picture rendered in the style of Rick and Morty. And so this whole process can happen automatically and can be applied to any image. So I thought that was fun. But my real area of expertise and interest is in biomedical applications of artificial intelligence and machine learning. So I do most of my research in bioinformatics, particularly molecular bioinformatics, so very low level, DNA, protein kind of stuff. But I do know a little bit about medical applications as well. AI in medicine actually dates back to the early 80s when really the first AI system for medical diagnosis was constructed. But it didn't really take hold. Doctors did not trust computers to do their diagnoses for them, even at the time, the diagnoses were pretty accurate. There's a lot of challenges in doing this, both the practical and ethical. We have things like HIPAA restrictions on how data can be utilized by different researchers. It has to be de-identified. We can't have certain things. Recently, the NIH passed a rule that says that sequence-based data, DNA sequences, RNA sequences, are inherently not de-identifiable. They inherently identify someone. And so those things can't be transmitted without a lot of proper consent and understanding. There's also just some kind of low-level practical things. Not every doctor calls every disease the same thing. Not everybody writes down the same terminology or in the same order. And so you wind up with this language understanding problem that's sort of a core of a lot of AI, but makes a big difference with medical research. One way that we're trying to do better with that is actually with electronic healthcare records. These have been around for a while, but if you've been to a doctor or a hospital recently, you've probably had them enter your information into a computer system. That push was really spearheaded by the Affordable Care Act that included money for doctors and hospitals to upgrade their systems and try to standardize how data is collected and stored so that we can do the kind of machine learning and mining of that data to try to improve healthcare outcomes. There is a huge potential for increasing our understanding based off of the data that we're now collecting to understand better what tests work well, what treatments work well, what are most cost effective. Prior to coming to Trinity, I used to work at a place called the Jackson Laboratory. And when I was there, we were in negotiations with Aetna to start doing analysis of their data that they had collected. And I was kind of shocked to learn that they didn't have any data analysis people on staff. That seemed like something that a big company like Aetna should do. I don't know what the state of that is now, but I assume that they're starting to make strides along those lines, because it would definitely be in Aetna's best interest to determine what the most cost-effective tests are or treatments are. There are some more very specific diagnostic tools in use that are AI-based, particularly in doing things like cancer diagnosis. So cancer diagnosis is typically done through images. They'll take a section of a tumor and a specialist will look at that picture and make a diagnosis. And we've gotten so good with image processing though that we can train an artificial intelligence system on that and outperform even the world's leading experts in terms of diagnosing particular types of cancer, which is important for deciding how a tumor is going to be treated. We've also seen a lot of work, especially recently, in drug discovery and drug effect predictions, given the very large collection of data that we have about this. Drug discovery has really changed over the years. And one of the things that's very common now is the NIH has a collection of about 30,000 compounds that we know are safe to use in people, but we don't necessarily know what they do or what diseases they could potentially treat. And so we can treat cell lines or animals with these drugs, generate a huge compendium of data, and then again, starting from a few drugs that we know what they do, we can see what other drugs maybe are similar to that drug and their effect, and try to pull out patterns in either a supervised or an unsupervised way. So much like with our images, there is a lot of challenges here, particularly bias. There is a lot of bias in whose data is well collected and what data we include in medical databases. Women and people of color tend to be less well studied in terms of clinical studies and trials. And there's also the problem of rare variants. Most studies tend to gravitate towards quote unquote the mean person, not like the angry person, but like the average person. And so if you have some rare genetic variant or rare thing occurring in you, that's not going to show up in the data that we're trying to learn these things from. So that's, some of the medical applications of AI and machine learning. There are a lot more applications in biology beyond just medicine. So more, maybe basic biology knowledge. A lot of biology is still really largely unknown at the molecular level. The human genome was first sequenced, completed genome was published in 2001. So we've had it for about 20 years. And I like to describe that as knowing the parts list. It's as if you had all of the parts to make a car. Someone gave you, you've got 4 tires and 2 axles and an engine and a tailpipe and whatever else goes in a car. But you don't know how they all fit together or what function, like I don't know what a carburetor does. So I don't know where to put that in the car. And we're sort of at that point with genetics. We know what all of the genes are, but we don't know what a lot of them do. In fact, half of human genes have never been named or have never been published in a paper that used their name directly. They've all been named, but about half of them have never truly been studied. So that's a huge endeavor. We've got, about 25,000 genes in human, many more gene variants of all the different proteins that they can produce. And so we do have technologies though that can measure things about those genes. We can measure how turned on or turned off those genes are. We don't need to make all of our genes all of the time. So every gene basically has a little dimmer switch attached to it. And we can measure the state of that dimmer switch for all of the genes in a cell at a given time at once in a single experiment. And lots of those experiments have been performed. So that creates this huge database that we can apply machine learning techniques to try to predict the function of proteins that we don't know what they do. And so that's really the focus of a lot of what my lab works on. Again, there's a lot of challenges here. Biological data is notoriously noisy. That noise tends to not be the statistical random noise that we like to think about, where we can just say, oh, it's a Gaussian, just, forget about it. The noise is often very correlated with real biology that we may not even know exists, or with experimental flaws. One of my favorite data sets has a huge bias in it that is related to the temperature of the centrifuge on the day the experiment was run. So that's the dominant signal in that data set. So we have to deal with all of those kinds of issues, and sort of your base machine learning methods, a lot of the original machine learning methods aren't very robust to a lot of those statistical challenges. Things like neural networks tend to do a lot better. And so that's why I think we're seeing this shift to maybe more abstract, but better performing algorithms. So that's kind of what I wanted to start with. And then I'll pass it back over to Dr. Lewis.
Actually, before you do that, I just want to share a little story. So just want to go back to your Zoom backgrounds for a sec.
Yeah,
so
yeah.
That reminds me, I don't know if you even remember this, but for one of the finals for the computer vision class that I took with you, Dr.
Oh, yeah.
You asked us to write a short program, a simple program that automatically generates computer art in the style of Mondrian.
Of Piet Mondrian, yeah.
Remember that?
I do. I have the whiteboard you gave me, yeah.
Yeah, just want to share that. Good memories.
It's a great assignment. I love it.
Okay, I have to ask you. You say short, and you use air quotes.
Yeah,
how long did your short program wind up being for this?
I don't remember honestly, okay. But it was the last question in the final. So
there is a relatively short solution, but yeah.
It definitely induced a lot of stress for all of us.
That sounds like, Professor Optimism, that the students will find the short solution.
Right.
Actually,
Right.
most people didn't even get to that question, I remember. Anyways. Well, Dr. Lewis, are you ready?
Sure. So while my specialty is, somewhat far removed from biology, unless you go into the astrobiology part, the astrophysics and planetary science, that is not the part of artificial intelligence that I fundamentally find the most interesting. The areas that I really like to kind of read up on and explore are areas that deal more with robotics, the bringing of AI into the physical world and having hardware for it. And it's interesting to note that in many ways, I think this has been moving more slowly. The areas, I think for all technology, everything where you're only dealing with bits and you're only dealing with generally electrons representing bits. But the cool thing about bits is bits aren't physical. So it doesn't have to be electrons. It could be photons. It could be any other type of thing that can represent a 1 or a 0. Those areas have had remarkable exponential growth in their progress, in large part because they're detached from the physical world. The parts that have to bring back in the physical world have moved a little bit more slowly, but I think they can be more impactful for that reason. And one of the things that's significant about machine learning and AI, I teach the machine learning class at Trinity, and one of the things we stress, so in computer science, we're often talking about algorithms. We take problems and we try to figure out how you solve those problems on a computer. And at least historically, the way you've done this is a human figures out a series of steps to use to do something. The analogy is like a recipe. Machine learning, though, is primarily used in the situation where you don't have an algorithm. Instead, you have a whole bunch of data. You have a whole bunch of data that you can play with. And especially in the supervised learning, you have a whole bunch of data that you know the right answer for, but you can't explain how you got there. And in the robotics field, a lot of this exists. When you think about things you do on a daily basis, you can't explain to someone how you walk across a room without falling down or tripping over stuff. But an example of what you could probably explain to someone fairly well how you alphabetize a set of folders. Okay, and so in computer science, that's sorting. It's a standard algorithm that we have lots of ways of doing. But the machine learning comes in when we don't have a nice explanation for how things happen. And instead, we try to get the computer to learn how it happens. One of the other things I find interesting, because it's 2020 and we're doing these things, normally the 3 panelists would all be in the same room potentially for this event, but because it's 2020, we try to avoid being in the same room as other people as a general rule. And this actually has an impact upon the demand for AI, especially in the robotics area. So some examples of things that are significant. Amazon every year, so you're probably aware that Amazon's warehouses are already very, very highly automated. They have a bunch of robots that run around that move inventory from one place to another. It's possible you've seen videos of this. The primary robots, they bought a company called Kiva, and they basically lift up these bookcase-like structures and move them around the warehouse to go to the right person to fulfill an order. And there is, of course, an AI that's behind that is trying to make sure that things get to the right person. But one of the aspects that is still involving humans is what's called the picking. So once the inventory comes over to a person who actually has to grab the right item out and stick it in a box. And that act of grabbing the item out and dropping it in a box is completely done by humans currently. And Amazon has been running a competition for a number of years now. And part of this is they'd like to get rid of the humans for their obvious economic incentives to not have humans. But in 2020, there are other incentives for this, which is the human might be sick, right? The human might have coronavirus. And if you're doing, these 24-hour turnarounds on shipments, that coronavirus might be active on the stuff that you get. There have been a number of cases where it seems like the most likely vector for getting it to the person was something that they bought. And so it was the handling of that. And so having a robot handle this, an interesting statistic I found was that in January of 2020, online shopping accounted for 13% of sales in the United States. And in May, it was 80% of sales. So an autonomous picker, having the AI that can identify what it's picking up, grab it, and stick it in a box, has huge applications and could actually do nice safety things for us in this, this year that wouldn't have been in the past. Another area where this is significant is food service. So I have been following for quite a few years companies that are working on basically becoming your local burger flipper. The devices that can, and they're not just flipping the burger, they build the burger. One of the primary pieces of hardware for this starts literally from raw meat and grinds it and could make mixtures of so it wasn't necessarily what you'd buy at McDonald's. These were for gourmet burgers. They could give you a mix of different types of meats by grinding them up, making the patty, cooking it, and building the whole burger from there on out. They also sliced all the vegetables and stuff like that. So very highly capable. And they've been active for a number of years, but what has happened this year is that the desire for fast food companies, even both higher end and lower end, has gone up because there is now a stronger push to not have humans handling your food and to get the humans out of it. So there's actually quite a few companies that are working on robots that are able to flip your burgers and make your fries and handle a lot of the processes that happens there. My personal favorite field for AI though is autonomous transportation, and DARPA had a competition for autonomous cars that went on for a number of years. In the first year, all they had to do was make it across a desert. They didn't have to stay on any roads. They just had to not get trapped in sand dunes or anything like that. And I think one team managed to pass that year. This competition wound up leading to the Google Car project, which we now know as Waymo. And Waymo has been operating in the Phoenix area, giving people autonomous rides for 2 or 3 years now. I know, time flies. As I said, though, this moves a little bit slower because there's the robotics aspects and because humans are crazy drivers. And so you have to interact with them as well. Tesla has their Autopilot, which is constantly gaining functionality. In the last year, my Model 3 has gone from just being able to do interstates fairly well to now stopping at green lights and stop signs. And if a car is in front of me following through, or stopping at red lights, not stopping at green lights, stopping at red lights and stop signs. And if it's following another car, going through green lights on its own, making those determinations. So they've added a lot of functionality there as well. Here again, the desire for autonomous transportation is larger in 2020. Uber and Lyft saw significant drops in the number of ride sharing, though they've made up for it by delivering food, is my understanding, because food delivery is way up. But the number of people who want to get in a car with a random other person and take a ride has gone way down. And this is another area where the ability to do this with an AI driving and have the system fully autonomous and basically take humans out of the loop can be very, very helpful. And who knows, I think psychologically for society, I think these desires to have more things be autonomous, the coronavirus has probably changed the way that we're going to view autonomy, because it obviously has implications for the workforce and aspects there. But now it takes on a different light for things like safety. And I'm very interested in seeing how that moves forward. And one of the things that Dr. Hibbs mentioned was the role of computer vision. Every one of the applications that I just mentioned is actually a huge computer vision problem. Turns out that picking isn't just about the robot hand, it's about being able to identify the thing you're picking up and try to grab it in the right way and then drop it properly in the box. The vision part is as much a problem as the robotics. Food preparation, being able to identify the things and handle them properly, and obviously autonomous cars have to be able to see the environment around them. And And for like Waymo, that involves other instruments like LiDAR. But in the case of Tesla, it's all cameras. 100% of their system is based upon computer vision. But the advances in computer vision have other interesting implications. Things like, so Dr. Hibbs mentioned the bias issues. There have been other interesting articles that have come out. Facial recognition is a huge area for this. And a number of jurisdictions have reduced the amount of facial recognition that is used by, for example, police forces, because of some of the challenges that they've run into with doing this well. It can also go in the other direction. Facebook recently announced a thing called Project Aria. And this is, I could say it's their version of Google Glass. I don't know how quickly they intend to move this out to a consumer product, but it's a pair of glasses that are slightly larger than normal, mainly in the sides, because they have to hold batteries and a small computer in them. But part of their goal with Project Aria is to do for indoor spaces what Google's Street View cameras have done for outdoor spaces. So, you know, Street View has been driving around all over the place, taking pictures of everything. And that's why when you pull up Google Maps, you can not only see, you know, the satellite imagery, you can go down and see what it would look like from your car there. Facebook intends the first step in Project Aria is to have their employees walking around with these headsets on and literally map the interior of every building that they go into. Okay, so that you can get highly detailed maps of the interiors of buildings. And of course, you will see every human that is in the building along with them. And if they walk into a private residence, if they happen to see a paper that's sitting on a desk that had private information on it, how does that get recorded? What gets used? How much of that can be thrown away by artificial intelligence? Here again, this is a talk on artificial intelligence. So it's not just capturing this stuff, it's processing it. And one of the things that Facebook has to do is throw out the information. They say, we're gonna get rid of all of the personal information, all the people's faces and whatnot. But that requires that the AI be able to identify what that is, because there's gonna be such a huge volume of information that you're not gonna have humans that are capable of going through it. It will have to be viewed by AIs, and it will have to be done autonomously. So I'll stop there. Make sure we have some time for questions and whatnot.
Awesome. Well, thank you, Dr. Lewis and Dr. Hibbs, for all of the insights. We definitely have a bunch of time for questions. Before I open the floor for audience question, though, I would like to remind you to submit your questions using the Q&A tab. And I'll also like to ask one question for myself to both panelists. Do you see machine learning playing a big role in education? And how does Trinity CS department plan to facilitate learning with artificial intelligence?
We're going to replace all the professors with AIs, and then we'll just collect the money. That's
right. Yeah.
Sounds pretty good to me.
Do you want to start, Matt?
Go ahead. Yeah.
Okay. So, so outside of the computer science department, the biggest, so historically, when I first saw IBM's Watson win Jeopardy, I was like, for me, that was like, this is the potential future tutor, right? And the technology has gone into that. For example, Georgia Tech has an online master's that they run through Coursera. And one semester not that long ago, they decided to augment their TA staff with an AI. And they gave their AI a nice human name, and they didn't tell the students it was an AI. The students just thought it was another one of the TAs. This TA happened to be really fast at answering questions. And what it would do is it would go through the questions, and if it thought that it knew how to answer them, it would answer them. And if it didn't, it would throw it to a human TA. And so I think the autonomous TA answered something like 70% of the questions for the semester. There was just this one really go-getter TA. A few students actually figured it out when they were going through it. For large-scale education, that type of thing is definitely going to exist. I also have to say, though, when I think about AI in education, the biggest news for me is this GTP3, which is the OpenAI project. They analyzed huge amounts of English writing, and it's a very, very, very large neural network that has recently been licensed, I think, exclusively to Microsoft for doing some work. But a lot of the demos people have shown of it is you give it like the prompt for an essay and it writes an essay. And you can even find there's some news articles where people have done this. I saw one where it was an article where they had asked the computer to generate an essay saying that it was not a threat to humans. It's a very humorous essay. But every example that I have read of this, I'm like, oh, that could be a college student's essay. I have known college students who write at the same level of capacity of GTP3. And I feel really sad for my humanities colleagues who I can just see in a few years when this type of technology becomes more generally available, a student literally just takes the prompt for their essay, feeds it into this AI, and they won't all be turning in the same thing because it can provide multiple different outputs and they can select the one they like best. So yeah, there's some interesting things there beyond what we teach our students.
Yeah. Well, and I think we're also going to see just more data get collected. There's been this big move to online textbooks that might have, thousands or tens of thousands of students doing questions in that online textbook, and just having the data of where did students spend the most time, what were the hardest questions, on that kind of scale will let us to start do the kind of machine learning and data mining to perhaps improve pedagogy, even beyond, just fully automated teaching.
Awesome. Thank you both. We do have a ton of questions on the Q&A tab. Right now we have 11. Not sure how we're going to go through all of these, but we'll try. So the first one is from Daniel. Why is self-driving vehicle performance typically compared to perfection when the status quo of human-operated vehicles has a well-documented record of imperfection? What can be done to overcome this unequal and unfair comparison?
Thank you, Dan. This is actually one of my biggest questions, and every time I get into discussions with people about autonomous cars, this is and I think this applies to other areas of AI too. Very often when people talk about AIs and computer solutions to things, they don't want to accept they compare it to perfection. They don't want to just view when it is better than the alternative. And there have actually been some studies done on this as to the benefits of adopting autonomous cars as soon as they are better than humans, as opposed to later. I think it was the Rand Corporation did a study on this. And it turns out that they make a very good case that adopting autonomous cars as soon as they are even really close to human level saves a lot more lives. Because as we've been discussing, what makes these AIs work is vast amounts of data. And so it turns out that having them out on the road driving makes them better. And the only way that you will get them closer to perfection is if you actually allow them to be out on the road and collect a whole bunch of the data from this. And so allowing the autonomous cars to start driving as soon as they are close to human level winds up causing them to improve much faster and saves a whole bunch of lives, as opposed to waiting until they are significantly better than humans, in which case the humans keep running into each other and killing each other. The challenge with putting this out to the public, and that was part of Dan's question, is how do you convince people? This is an emotional topic. This is not based upon rational analysis. And I worry that in some ways you're not going to convince the public for that reason. Your best bet will be to convince policymakers, convince the people who have the ability to either allow the cars on the road or not, that this is the key to safer roads and better cities in the future. Because there are other advantages to having autonomous cars, like the lack of parking lots. The ability, if you take a dense city and you replace what is currently happening with a whole bunch of autonomous, Waymo or whatever vehicles, you get rid of all the parking spaces. It opens up a whole lot of area in there. It can become green space or whatever else you want with it. They can drive themselves back out because they talk to each other and interact better. You have much greater potential to reduce congestion. There have been studies that show that if you just turn something like 30% of the cars on the highways to autonomous cars, the level of congestion goes down dramatically, because most of your congestion isn't actually caused by someone having a wreck. It's caused by hard braking and stuff like that. And there's cool simulations that show how when one person brakes hard, you get these compaction regions. You've all seen these traffic jams that are happening, and you're waiting to find the wreck over the next hill, and it's never there. That's because there wasn't a wreck. It was someone hit their brakes too hard and caused this entire thing to happen. Of course, then they went away, and it's everyone else who suffers. But putting in just a certain fraction of autonomous cars that do a better job of spacing out actually removes a lot of that congestion. And so there would be many benefits to getting these on the road earlier. You're not going to convince the general public. I think convincing the policymakers is the way to go there.
And insurance companies.
And insurance companies, yes. I think for me, the way that autonomous cars really get onto the road is a positive feedback loop. You have to get enough of them on there that the insurance companies realize, oh, they aren't having wrecks and the humans are. And then the insurance policies, the humans start paying more and the autonomous vehicles don't. And that becomes a positive feedback until it becomes almost so expensive to drive your own car that the only people who could do it would be wealthy and everyone else can't afford the insurance on it.
Interesting. Wow. Sounds good. So one question from Carlos. As a practicing physician using EHR, I'm not aware of any studies showing improved outcomes or decreased mortality. Are you guys aware of any positive data on this?
So we're still in pretty early days with EHR, and I know that there are a lot of people actively working on trying to generate systems to determine better guidelines for best practices and what tests or treatments are most effective. There's still a few big hiccups. One of them currently is that there's basically 3 large companies that make EHR software, and they have intentionally made their file formats incompatible, so that when a hospital or doctor goes into one, they can never transition into another. And it also makes it hard to collect data across those platforms. And you also have to jump through a lot of HIPAA hoops and regulatory hoops to do that. And there's relatively few labs that have gone through all that trouble to start doing that analysis. I anticipate that we'll start seeing more from that over the next 5 to 10 years, but we are still in relatively early days of doing EHR record analysis. Yeah. So I'm not aware of any studies yet showing that.
That goes to the general rule of computer systems. The more secure it is, the harder it is to use.
Yeah, and HIPAA regulations are tough. I mean, like you have to go through a lot to get access to some of that data.
All right. Thank you, Carlos, for the question. Next, we have one from an anonymous attendee. With the advent of additional AI-driven automation potentially making a large number of jobs obsolete, Uber fast food examples, to what extent do you think developers are obligated to consider the ethical implications of their design?
Okay, we've got 12 minutes on this. Man, okay, because I don't know who that is, but they opened one of my favorite topics, and I could probably teach an entire class where we discuss this. I think I actually did one semester teach an entire class where most of it was discussions of this. Short answer, since we don't have an entire semester to explore this. Yeah, this has to be considered, but I'm not certain that the consideration is primarily on the backs of the people developing this software. There has always been this general trend that we automate stuff. Okay, so you can go back to the original automation of things like textile production, and we have the expression Luddites coming from that era because people were opposed to the automation. Automation displaces jobs, and there are multiple ways you can respond to it. And I really think that what we need to do as a society is figure out not how to stop the automation, because I actually think that's a losing battle, in part because we're a multinational world. Not every country is going to stop automation, and the countries that do are going to lose out to the ones who don't for at least a while, and then they realize, oh, that was a stupid thing to do, and then they'll bring in the automation. instead, what you have to do is figure out what we can do as a society to make it so that automation, putting people out of jobs when they get automated away, doesn't destroy their lives. Okay, so it doesn't suck and it doesn't destroy society, because you can also have this situation where this will further increase the income inequality, the gap that already exists, and it's already growing. And I think that automation already plays a role in this. And so addressing those issues is going to be key to making it so that the future of automation doesn't completely tear our society apart. My personal solution to this is a basic income. I was very happy to see that someone actually made it fairly far in the presidential primaries who was talking about a basic income. I think that we have to consider, and there are a variety of reasons. Okay, so I'll stop there because otherwise we get the whole semester version.
Sounds great.
No, I think it's huge. And I'll just chime in and say, automation historically, we've developed new jobs to replace those people, right? We automate, auto workers, and then we have an increase in service industry or some compensatory increase elsewhere. It's unclear that the intellectual power that's going to be replaced by AI is going to result in jobs somewhere else. And that's part of the problem, right? Is that this time might be different.
Well, and even if you assume it isn't, okay. So here's as the standard argument is, no, it's going to be the same. We've always gotten rid of jobs. But what people fail to acknowledge is that in 1900, the average American dropped out of school somewhere between 4th and 5th grade. Okay, so that was the amount of schooling that was needed in 1900. In 2020, if you want to participate in the economy, it's really hard if you don't have a college degree. And that would be 16 years of education. We've added about 10 years of education in the last roughly 100 years. So let's say the future is exactly like the past. Are we going to require people to stay in school until they are 32 years old to participate in the economy? Because you will have to have that level of knowledge and skill to compete with the AI. I don't think that's a sustainable view. And so even if you assume it's exactly like the past, it's still not going to work.
And AIs are getting smarter exponentially faster, and people are not. So.
Though actually there is a benefit. Moore's law has slowed, and until something else comes out that can replace silicon, it will die in 5-6 years. That's actually helping the social dynamic here. If Moore's law had not slowed, it's actually holding back what we can do with AI.
Actually,
yeah, I mean,
yeah. Well, this is a discussion area.
Yeah.
But we have other questions too. 22 of them now, dang.
I know, it's crazy. So one from Mr. Cover. So he was a student of Dr. Hibbs as well. So his question is, aside from aforementioned difficulties in data collection, aggregation / access, what do you think the major obstacles to AI / machine learning applications in healthcare will be? Along those same lines, what subdomains of life sciences do you think will be the least impacted or least advanced by AI / machine learning developments over the next 15 years?
So let me try the first question first. So one of the challenges that I worry about, well, a few of the challenges that I worry about is the rare variant problem. All of what we're learning from the medical literature, we need enough examples of something happening in people in order to detect a pattern. And something that happens in relatively few people may be very serious for those people, but we're not going to be able to help diagnose that. That's not going to turn up in our data sets because of the bias. The bias is a huge issue for many reasons, but that rare variant, even if we made our input data sets completely unbiased and perfect, we would still miss those kinds of issues. Also, the structure of noise in biological data is so highly correlated with phenomena that we don't understand that that's going to be a challenge. So I think those are maybe two of the largest stumbling blocks to taking sort of existing methods and applying them there. Trying to think about parts of life science that AI isn't really going to be useful for, I'm kind of struggling to, like, my initial thought is like zoology or something that's very, you know, qualitative rather than quantitative. But I think even there, we're starting to see applications of image analysis for identifying subspecies. And so I think we're going to see AI kind of everywhere, you know, honestly. Yeah.
I have to throw out one of my favorite quotes is Ernest Rutherford, which was, "Physics is the only true science, all the rest is stamp collecting." Which I think at the time that Rutherford said it was actually a very true statement, because everything else was just trying to figure out taxonomies of stuff.
Yeah.
And what has happened over time is that the realm of what is really science has been growing, and AI, I think, is required to drag a lot of biology into it, because the amount of data that you need to scientifically explore biology is so huge that it can't be done with humans.
Yeah, no, a lot of biological analysis, just, it's impractical for a person to do it anymore. I mean, you can run one experiment and generate 4 terabytes of raw data. Like, no human can, you know,
No.
I marvel thinking about the old days where people literally printed out sequences on paper and, like, you know, we're moving pieces of paper around to try to do sequence alignments. And I'm like, now that's just dumb. Yeah, computers do all that work.
Very true. We have a few questions on, let me scroll down, general AI. So this one is from Rama. What is your prediction for when we'll move past ML and achieve general AI? In which fields do you think AGI will first appear?
So I would say we're starting, it depends on what you mean by general AI. But I think one of the better examples of this recently is in game playing. The game of Go is this, you know, very ancient game that was considered very challenging. I know when I went to grad school, that was considered like the holy grail of AI, right? Like, if you could make a system that could play Go really well, that would be great. And we have now. AlphaGo was a system out of Google, right? Yeah, out of DeepMind. That has beaten the world champion Go players. And then they followed that up, and it was a bit more of a traditional machine learning technique where it would play against you know, real people as well as other AIs, and use the database of known moves and stuff to initially train. And now they've moved to this system that they call Alpha Zero that doesn't need any of that. All that it needs is the rules of the game, and it can learn to be the best player of that game in the world. And now we're even starting to move, and that's incredibly impressive. But at least with Go, there is a determinable number of states that something can be in. But now we're starting to see AI outperform the best game players in the world in things like StarCraft or League of Legends. And that, you know, sounds kind of trivial, like that's the game that all the kids play. But that's actually a lot more real-time decision-making than a game like Go. And the fact that we're seeing these AI systems perform well in those kind of virtual areas, I think means that it's not going to be too long before you see them perform well in more real-world kind of situations for real-time decision-making.
And don't forget poker.
And don't forget poker, yep. Well, for that matter, the stock market, right? Like AI has completely ruined the stock market, because that is essentially just gambling for AIs at this point.
Can you do a better job than the AIs of predicting what's going to go up and down?
Exactly. Yeah.
But, you know, last year was when an AI for the first time beat the best poker players in the world. Right. And that was also a major breakthrough, because one of the things about poker is you have incomplete knowledge. Whereas so many of these other games, you know, Go and chess, you have the entire board, you know everything there. And in poker, you don't know what's in the other person's hand, which opens up a lot of possibilities. But AI has now beat that as well.
Sounds good. Wow.
Does it?
So, but wait, and if anyone didn't know, if you play online poker, stop, because you don't know if you're playing against an AI. If you're playing against an AI, your odds of winning are 0. You could be playing against a machine that will beat the best humans in the world, and it could just be some teenager sitting there who got a copy of the code, and they're just, you know, taking all your money. So.
All right, we have time for one last question. This is an interesting one from Margaret. What are your thoughts on Elon Musk AI to augment the brain through chip implants?
Do you want
I thought it was just going to be, what are my
biology
thoughts on
that?
Elon Musk? And then that would have been an easier question. It's interesting. I think we are going to see more implanted devices. I think we're still a ways away from an implanted device actually helping you think faster. But I think something like what Mark is talking about with the Project Aria glasses that are going to be an overlay on the world and are going to augment your abilities, not by modifying your brain chemistry, but by providing you additional contextual information as needed, that's going to be the next step. Yeah, Iron Man. Eventually that might be implantable. That might, I think it's more likely to be like a contact lens or something that I think people are going to be very reluctant to implant things in their brain. I'm sure it will eventually happen, but I don't think Elon Musk is going to be the person to make it happen. Maybe. But.
Yeah, unfortunately, I have a tab up, or I had a tab up with the Neuralink, the announcement from them, but I never got around to watching the full thing. This goes into when you deal with looking at the future of computing and predictions. There's been this idea of the coming together of humans and technology and kind of solving all problems with this infinitely capable AI that winds up building better versions of itself.
Skynet. Yeah.
What?
Skynet, right? Yeah.
Well, kind of, except there have been other views that have been more favorable towards humans. Right. And really there are three parts to that puzzle, and two of them, this question addresses the third. So you have the hardware part, computers getting faster. You have the software part, which that has been growing leaps and bounds with the advances in deep neural networks. And then there's what is often referred to as the wetware, which is actually interfacing with the humans. And I would argue that in the last 20 years, the wetware has been the laggard in this. It's the one that doesn't keep up. And unfortunately, when it comes to scenarios, that's the one that prevents us from hitting Skynet.
Well, and yeah, I mean, that's kind of the angle that I come from it too. I'm not a neurobiologist, but I know enough about the brain. I've seen enough neurobiologists give talks to know that we don't know how the brain works. And so I would be very worried to mess with that.
Well, and now a lot of these things do, you're putting in an implant that has nanowires that is reading signals from your brain. And I guess it does interface with it, but at least the first step is you use that. It would be for someone who has like an amputation or something like that. And you read that and you learn this signal means raise their arm. This signal means, clasp the hand type of thing. And you use that to control outside stuff. And then you have to figure out the feedback. And I guess that's what you're worried about, because, okay, now we want to say, okay, you're touching it. What signals do you send into their brain to make them think that?
Yeah, like reading from a brain, I'm more okay with. Writing to the brain seems problematic.
Yeah, I think we had a question somewhere about viruses, and now we've just taken it to a whole new level where the hackers are trying to hack into your brain.
I mean, it's happened with pacemakers and stuff. There's no reason it couldn't happen with,
Pretty scary. So recently I learned this really shocking fact to me, which is we, as of today, don't even have a 3D reconstruction of a fly's brain, let alone a human brain. So we are just really, really far in this journey.
Yeah.
Anyways, we're almost at time. I would like to close the Q&A session with a really wholesome message from Brett. He says, I would just like to say hi to Mark and Matt. Times were much simpler when your homework was the majority of my stress. I completely agree.
Didn't stop Brett from complaining about it then, though.
That's true. That's true. Yeah, adulting is tough. Yeah, I think we have 1 minute left. Let me just close the webinar with the final words. I hope you have enjoyed this webinar. You will receive a short survey following the webinar. It will take less than 3 minutes to complete. Your response is crucial for us to determine if the webinar was a success. Your response will also guide enhancements and improvements for future webinars. For additional Learning Together content, including other webinars, podcasts, and book club information, please visit the Lifelong Learning page on the Alumni site. Go Tigers!